remember not so long ago we did a problem like this when it came down to solving a quadratic equation by taking the square roots, right? So we had an equation like this: 2 times x plus 2 squared equal 98, and we divided both sides by 2. We had x plus 2 square equals to 49, and then we found the square root of both sides. So we have x plus 2 was equals 7, and it was all plus or minus 7, apologies, and this was all good and dandy. So we had x equals to 7 plus 2, which is 9, or negative 7 plus 2, which is negative 5. So what we're going to do here now is do the opposite. So while we had to take the square root of both sides, you're going to see us do an equation where you have to square both sides. So we're doing the opposite. So for example, you're going to have equations with square root in it. So we're going to have example x minus 7 equals to the square root of x minus 5. Here it was squared and we had to take the square root, which is like saying the opposite operation to find our x. Here we have the square root, so guess what we have to do? We have to take the square of both sides. We have to square both sides. So this is x minus 7 squared equals to x minus 5 squared. And we know the rule, when you square a square root, you get what's inside. So this is, we'll have to expand this expression on this side of the equation, and that should give us x squared minus 14x plus 49 equals to x minus 5. So in order for us to work out this equation, remember it has to equal 0. So x squared minus 14x, I'm going to transpose my x and my 5 term, and I put them together, minus x plus 49 plus 5 equals 0. Looking good. So here we have, now I'm going to combine my like terms. We have x squared minus 15x plus 54 equals 0. So here my leading coefficient is 1. So I know if I find a factor from our basic in factoring rule, and if this confuses you, then you should not be here. You should know how to factor before you get into doing equations of this nature. So if I look at 54, my C term, or my AC, 1 times 54 is 54, and I find two factors, I know that 9 and 6 will give me 54 when I add them, and this is positive. So that means an addition has to occur for me to get my middle term. And because it's negative 15, it means I have to have two negative factors. And that makes sense because negative 9 times negative 6 is positive 64. But when I add them, I get negative 15. And this, because the leading coefficient is 1, by in hindsight, my two factors will be x minus 9, x minus 6 equal to 0. And then I'll solve for x in each scenario. Now it's a little tricky here when you're taking the radical to solve quadratic equations. It doesn't always mean that both solutions are correct. So in order for you to find out if both solutions are correct, you have to check, right? Check to see if both solutions are correct. So if I substituted 6 back into my original equation, I'll have 6 minus 7 equals the square root of 6 minus 5. So this is actually minus 1 equals the square root of 1, which is 1 minus 1 equal 1. And in this case, that's not true. So 6 is not a solution. So let's check to see if 9 is a solution. So I'm going to substitute 9 minus 7 is equal to the square root of 9 minus 5. So here 9 minus 7 is 2. And this is actually the square root of 4, which is 2. So 9 is a solution. So don't just do a problem like this and then call it a day. You have to check to make sure that they are the correct solutions. All right, so 9 is the only solution. All right, let's try another one. So here we have where both sides are radical. So this is the square root of actually y only plus 1 equals to the square root of y plus 5. Step it up a notch here. So again, we're going to have to, let's first try to isolate because we're looking for y. So let's first try to subtract 1 from both sides. Okay. And then, so that's root y equals to square root of y plus 5 minus 1. And now I'm going to square both sides. Okay. And let's see what happens there. Here, we're going to have, this is going to be y equals to y plus 5 minus 2 times y plus 5 minus plus 1. If you expand these two, this factor here, this is what you'll get. And now I'm going to combine like terms. I'm going to do that by, this is y. Also, if you notice, I can actually transpose one y to the other side, which cancels out. So my equation here is 0 equals to 6 minus 2 root y plus 5. So as you can see, this is a special type of problem that it requires an extra step. So here, I am going to transpose my 6. Now I'm going to divide my factor negative 2. So that gives me 3 is equal to the square root of y plus 5. So here we're back into the square root predicament again. So if you guess that we'll have to square these sides to solve for y, you guessed correctly. So now I have 9 is equal to y plus 5. Subtract y from both sides. 5 from both sides. So we have y equal to 4, and let's check to see if 4 is a solution. Let's see. So let's plug it back into our expression, which says y square root of y plus 1 is equal to. So let's go. That's the square root of 4 plus 1 equals to 4 plus 5. So we have 2 plus 1. That's 9. 3 equals 3. I'm sorry. Check. All right, guys. That's it for solving quadratic equations by taking square root. If you have any questions, you know how to find me.